If you've ever tried to 3D print a wheel before, you'll know that getting traction is one of the biggest problems, even with rubbery filaments like TPU. One way around that is to use a pourable two-part urethane to make a softer rubber tread, which can make a big difference. Sometimes, though, you've got a part that isn't really possible to pour. Let's talk about how to make that. I'm in the process of making some upgrades to Cinnamon Roll, my 1-pound combat robot. One of the things I need to do right now is make new shuffler legs because I want to change their shape to improve the walking stability. The robot uses shufflers to move instead of wheels, which work by moving individual legs up and down with an eccentric cam to walk. It's important, just like with wheels, to make sure that the feet of these legs each have a good grip on the floor so that the robot can move efficiently. To get a good grip, the bottom of each leg is made from a softer urethane rubber. The short explanation for why this gives better grip is that urethane is just a softer material. I've got a little experiment here to demonstrate just what a difference it makes. This leg is printed with regular TPU, and this one has the urethane tread that we've been talking about. I've also got a strip of paper here which I can put down on the table in front of me. What I'm going to do is press down as evenly as I can and slowly pull my hands apart, creating a mini game of tug of war. You'll see that every time, the winner is the one with the urethane tread. This doesn't really scientifically prove just how much more grip it has, but it's a lot. To get a better idea of just how soft the urethane rubber is, we can also use the shore hardness scales, which do a better job of quantifying how soft a flexible material actually is. The 3D printing TPU we're all familiar with comes in at a value of 95A. That's why a lot of brands market their TPU as 95A TPU. The urethane rubber I'll be using today is a 2-part liquid mix that cures to around 40A, which is a lot softer. The challenge ahead, though, is how to join the two materials together. 3D printing the base part out of TPU itself is pretty trivial, but joining it to the urethane is the problem. The issue is that the urethane and the TPU don't always actually like to stick to each other. Thankfully, the solution for this is already well documented. The answer is to make loops with geometry or features on the 3D printed part that the urethane can flow entirely around when it's a liquid. When it cures, it bonds to itself and solidifies around those loops to lock itself in place. An easy way to make those loops is actually an extension of a trick I showed before, where I used an additional part in the slicer to make mesh vents. This time, we'll use the 3D geometry created by Infill to create the loops for a rubber to grab. Since wheels have a thicker tread, all you have to do after this is put the hub in a mold and pour rubber around it. Unfortunately, that doesn't quite work for this application. The section of rubber that I want is thin enough that air can't escape when the rubber gets poured into the mold. The trapped air prevents more rubber from entering, resulting in voids being left in the tread, which is no good. One way around this would be to use a vacuum chamber to pull the air out, but I don't have one and don't want to pay for one right now, so I wanted to find a cheaper way to solve this problem. Turns out that by stealing concepts from injection molding, you can totally get away without needing a vacuum chamber at all. I've been experimenting with this method and have been having good success, so I wanted to share it because I haven't really seen any other videos documenting casting urethane rubbers exactly like this. Also, even though the example I'm showing is used for a pretty niche application, I think that the method has potential to be useful for a lot of other things too. One example that I can think of is robotic grippers. We're starting with the CAD model of the shuffler leg. The first step is to model the entire thing, including the portion that I want to become the rubber tread. We'll use this later to make the mold. Then, using additional features, I can create the portion that I want to make sure is entirely the 3D printed TPU. I do this by just cutting off the bottom of the foot where the tread will be. To switch between these, I just suppress or unsuppress the feature in the CAD, which adds or removes that cut. The final feature is one that cuts away the rest of the foot, leaving behind only the portion that will become the interlocking infill. This overlaps with the TPU part by a small portion to make sure that it's properly attached, and is a little bit away from the edge of the part to create a portion of pure rubber that will actually contact the ground. Again, this is a feature that I can suppress or unsuppress depending on what part I want to be exporting from the CAD. To make the 3D printed part, I export both the main section of the body and the interface portion as .stl files. In the slicer, I import both of them at the same time and select yes to bring them in together as a single object. Because I exported them from the same workspace, they line up when importing them like this. Now I can use the split to objects command to separate them and give us two parts that we can edit independently. Unlike the mesh video, we want them to be separate parts so that they intentionally overlap when printing, giving us a really good bond. It might be a little more messy, but that's okay because we're going to be casting the rubber over it. I'll make sure that my print settings on the main body are good, then change over to the interface. Here, I'll remove all walls as well as top and bottom layers, leaving me with only the infill. If I slice it, we'll see the main body with its solid print and the interface piece with only infill. Now, we want to change the interface so that we can make a number of loops that the urethane will flow through and cure into to lock the two parts together. I'll lower the infill density to make it easier for the urethane to flow through, and then change the infill type to make it have a 3D pattern. This will mean that instead of one big loop all the way down the part, we'll have a bunch of smaller ones to create more loops across the entire surface. I've found that about a 20% infill and 3D honeycomb pattern works really well for this part, but it's worth trying other infills and densities to find a good balance for the specific geometry of your part. Again, it might be a little messy, but there's no reason to care about it because we'll be covering all of it with the rubber. When we print it, we'll get the structural part of the foot along with a set of squishy loops across the bottom that we'll be bonding our urethane to. Let's take a look at making the mold now. This will be made in two parts, a bottom with most of our mold features and a top to hold everything in. I'm going to make these shuffler parts two at a time, so I've brought two of the legs, this time using the full model with no cutouts, into a CAD assembly. I've also added this block here, which will be the bottom of the mold. To get the cavities, I'll copy a sketch of the parts, using about a 0.1mm gap on non-critical features, but using no gap everywhere else to ensure a good seal. When you're finding the tolerances that work for you, you'll want to make sure that the fit between the part and the mold is as tight as you can get it while still being able to pull them apart. This is what I've found works for me. Now that we have that, let's add the features that will let us inject the rubber into the mold. To do this, I'm just using a basic syringe that I got at a local craft store because they're cheap and really easy to find. After measuring the diameter of the tip, we can make a hole of a matching diameter in the middle of our part. I'll also add a chamfer there to make it easier for us to make a good seal with the syringe when we go to inject. From there, we can add runners to allow the liquid rubber to flow into the cavity on each side. With these, the rubber will flow into the port, through the runners, and then along the edge of the mold. When it does that though, we need a place for the air to escape so we don't build up pressure. On each end of the foot, I'll add a small vent hole. This will also let me know when to stop injecting more material into the mold. When all four vents have rubber coming out of them, I'll stop. I'll also be making a few more holes higher up on the part. You'll notice that these aren't in the area that the rubber will be, and that's because we're going to use these as places to push the part out from the backside when it's cured so that it doesn't get stuck in the mold. There are other principles of injection molding that could also be useful, like adding draft angles to the part, but at this small scale, I haven't found them to be necessary. The last thing I'll add to this part of the mold is a copious amount of holes for M3 heat set inserts. Since we're going to be pushing the liquid in quite hard, we want to make sure that the mold doesn't leak and that it stays together. Using the inserts also lets me reuse the mold, which is a nice added bonus. For the other part of the mold, I'll just use a flat plate with matching holes in it for the screws. There isn't anything else going on here. I'm going to be printing these both out of ABS because I have a decent amount of it laying around, but just about any rigid material that you can use heat set inserts in should work. Once I've printed up both of these, it's time to prepare the mold. I'm going to start with the base here. I've got a bunch of heat set inserts to put in, and I've got my soldering iron to do it with. If you've never seen this done before, it's pretty fun. I'll gently line up my insert and then press down with the soldering iron. Once I'm sure that it's below the surface, I release the pressure and it solidifies in place. To keep the soldering iron from getting stuck, I've also got a pair of needle nose pliers to make sure that the insert comes off the soldering iron when I pull up. I'm going to do the rest of these and we'll tackle the next step. They're all in now, so we need to clean it up next. We want our mold to make a really good seal when we put it together, so we want the surface to be really flat. Because we were melting all of the plastic, we've got these blobs around the edges of the inserts. If there are any that are particularly bad, I'm going to trim them off now with an X-Acto knife. Now, I'm going to take both parts of the mold and sand the sides that are supposed to be touching. We want this to be as smooth as we can reasonably get it to prevent gaps where leaks could form. After that, things are going to be a little bit dusty. I'm going to wash and dry both of these parts to clean them up, and then I'll be ready for the next step. We've got the molds cleaned up now, so it's time to prep them. What we need to do is make sure that we're going to be able to get our part out, so we need a mold release, and we also need to make sure that we don't have it leak where we don't want it, so we need to have some kind of sealant. The good news is there's a cheap answer for both problems, which is Vaseline. I'm going to start by taking a toothpick and wiping a thin layer of the Vaseline anywhere that the rubber will be touching. So for me, that's this surface here and this surface here. Once I've got it on, you can see a really big difference between the coated and the uncoated side, so it should be pretty easy to keep track of your coverage. You can also hit it gently with a little hot air from a hairdryer or hot air gun to smoothen it out further if you want. Next, I'll be plugging up the holes that we made for ejecting our part. I don't expect anything to leak out because there should be TPU covering these holes, but it's better to be safe than sorry. I'll also put a little more around the channels where the TPU will be just to really seal things up. After that, I'll press a leg piece into each cavity, making sure that I can still see the gap where the rubber will flow. Then, I'm going to add more Vaseline along the top surface to make it seal better with the top plate. I'll also add a thin layer of Vaseline to the top plate, and then I'm good to seal everything up. I'll put the top on and then use all of the screws to hold it in place. Now, it's time to injection mold the urethane. I'm using Vitaflex 40 for this, which is a 2-part urethane. Before I start mixing though, I want to make sure that I have everything ready to go because once they're in the same cup, the clock is ticking. I have a paper cup to mix them in, a few wooden stirring rods, a small scale to make sure that we have the same amounts of each part, the mold, and the syringe. I've also got plenty of emergency paper towels on standby just in case there's a mess. You also want to make sure that you are doing this in a well-ventilated area because you don't want to be breathing in too much of this stuff. I'm going to start here by putting my cup on the scale, zeroing it, and then cracking open part A of the mixture. Using the stirring rods, I'll pour a small amount into the cup. I'm also wiping off the threads of the bottle with a paper towel to stop it from getting stuck next time I go to open it. I'll take note of how much I have on the scale. I have 10.3 grams of part A. I'll zero the scale again and this time pour in the same amount of part B. I'll wipe that and quickly close the container and then we'll mix the two parts. According to the instructions, we need to mix for about 3 minutes. Now, I've got my mixed liquid urethane and it hasn't cured yet, but it's starting to. I'll grab my syringe and put the tip in and then pull the plunger to fill it up. If you can, try to jostle it around a little bit to get any trapped air out of the syringe. It's time for the moment of truth. I'll grab the mold here and I'm going to firmly press the tip of the syringe into the hole that we made earlier. And then I'm lightly but firmly going to press down on the plunger until I see the liquid urethane has flowed out of all 4 of the vent holes. Okay, there we go. We can see that it's come out of all 4 holes, and now I'm going to let it cure for at least 24 hours before demolding. You get to skip that though, so welcome to the future. I'm going to start by removing all of the screws, and then we can take this apart. I've got them out, so now I can pry the top off. It can be a little tough, but we put that Vaseline down, so it should still come out okay. We can see that our rubber has completely filled the void, which is exactly what we wanted. I'm going to flip this over and we can use the ejection pins on the back to press the part out. Thanks to the planning we did ahead of time and all of the mold release that we used, those came out really easily. It's a little covered in Vaseline, so I'll have to wipe it down, but we're all done. The end result of this comes out looking really good. We have the exact shape we wanted, and it's thin, just like we wanted it. Again, this really wouldn't have been possible if we were just pouring the urethane into a mold, so using a syringe is actually a really useful trick, especially if you don't have a vacuum chamber. I've cut one of them in half to get a cross-section to look at, and you can see the boundary where the 3D printed loops and urethane rubber have joined to create this good bond. It's really cool to look at it in this way, and it's also always good to double check everything worked exactly like we expected. I have a lot more of these to make, though, to make sure that cinnamon roll is ready for its next competition, so I'm going to crack on with that. If you enjoyed watching this process and want to see more tricks like this, be sure to subscribe.